Git and GitHub is one of the most important skills that anyone dealing with computers must learn. So this is not only for IT. If you are a lawyer, an accountant, a writer, an author, or an auditor, you need to learn Git and GitHub. Why? We'll find out in this course. Before I start, I have Ahmed Afifi, who is going to be the main instructor for this course. So let's introduce Ahmed to you.
Hi guys, welcome to this course on Git and GitHub. Before we begin, I would like to introduce myself. My name is Ahmed Afifi. I have an MSc in computer science, and I'm currently an engineering manager with more than 6 years of experience as a developer. Throughout my career, I've worked on amazing projects varying in scale and complexity. But what they all had in common was the need to use version control. We will learn version control, specifically Git and GitHub, and why it's a very important aspect of any project. I want to highlight the importance of version control. Version control, specifically Git, is a very useful skill to master. No matter what background you have, I encourage you to apply what you learn in all your upcoming projects.
So before we hit the course, please, if you are not subscribed to the channel, hit the button, activate the notification so you will not miss any IT, DevOps, cloud, AI, machine learning, and more videos that are going to be published. Let's rock and roll.
Version control systems, or VCS for short. A VCS is defined as a software tool that helps software teams manage changes to their files over time. So let's see how version control systems can help us manage our files by going through an example, like creating a presentation. As we work on the presentation file, we will need to save our changes. There are multiple approaches that we can take to do this. The first one would be saving changes to a new file every time while keeping old versions as drafts for reference. This approach allows us to go back to an older version if we need to, but it can get confusing when the files pile up. Secondly, we can just save all our changes to a single file. This keeps everything clean and tidy, but puts us at a risk that we do not have any backups and we cannot easily revert to a different version if we want to. Lastly, we can use a version control system, which allows us to use a single file, but tracks the history of all the changes made to that file. Therefore, gives us the advantages of both previous approaches while eliminating the drawbacks. So let's see what my flow would look like if I use a VCS while creating a presentation. First step would be just creating the presentation and setting a file name, for example, then saving. Next, I will add a presentation theme for the slides and save that. Now I'll add some lecture content to my presentation and save. Time to spice things up a bit and add some illustration and save that. Now my presentation is ready. Let's say I want to create another version, but with some different contents, but I still want to use the same theme. Well, because I use the VCS, I can go back to the version of my presentation where I just saved my theme and start from there. So I can use the same flow, can start another lecture and add different content and save that. Now I have access to both presentation versions at the same time. So let's recap. What does a VCS allow us to do and why do we need it? The main feature of a VCS is that it allows us to have multiple versions of the same files, which means that we can recall a previous version whenever we need. By using a VCS, we can have great visibility on change history and product versions, so we can easily identify when an issue has been introduced. A VCS can allow multiple people to work on the same project at the same time, independently, and then combine their work. So that's an overview of what a VCS is. Now that we've understood what a VCS is, let's get started with Git. Git is a free open source version control system designed to handle everything from small to very large projects with speed and efficiency. Git is the most popular version control system in the world. In the annual developer survey done by Stack Overflow in 2022, it was revealed that almost 94% of all respondents use Git as their main VCS. This penguin might look familiar to some of you. Well, this isn't any penguin. This is Tux, the logo for Linux, and it's very closely related to Git. Git was actually created by Linus Torvalds, the founder of Linux. Its purpose was to help in the development of the Linux kernel. Git is universal, which means it's compatible with any major operating system like Linux, Windows, and macOS. We'll be mainly covering Windows and macOS. We'll see how to install and set up Git for these platforms. In this video, we will learn what GitHub is and how it is different from Git. GitHub is a web hosting service for version control using Git. GitHub boasts a lot of extra features that are essential for project management, like access control, issue tracking, and much more. To put it simply, Git plus the cloud equals GitHub. GitHub basically hosts the Git project you set up on your local machine on the cloud. This gives you access to the project from anywhere at any time. So following our previous example where we used Git as our VCS for tracking the changes we made while making a presentation, all of that is currently stored on our machine. We can now use GitHub to upload our full updated history to the cloud. Now that our history and versions are uploaded, we have the advantage of being able to access them from other devices, and the major advantage that other people can access the repository and work on it at the same time, which means that teams can work efficiently together wherever they are. This screenshot shows some GitHub usage statistics. This is from the official GitHub website. You can see from the staggering numbers how much of an impact GitHub has on the development community and beyond.
In order to be able to follow along the hands-on labs, you need to install Git, which is the software you will need to practice and follow along. And also, you need to install a visualization tool or a visual Git tool called Git Kraken. So how can you do that? It's very simple. Go to Google and type Git download. And then you'll have this website, gitscm.com. Click on downloads. And depending on your operating system, if it is Windows, Mac OS, or Linux, click on the link and you'll find the installation, exactly what steps you need to do and all that. So please follow that, and that is going to help you install Git on your machine. For Git Kraken, same thing. Git Kraken download on Google, and then you will find here the website. Click on download, and then you will also have the options for Windows, for Mac Apple Silicon, and for the different Linux. So choose the one that suits your machine, and please go ahead and click on the download and installation. All right, so let's go back to Ahmed.
Let's start learning about Git and how to use it. The first thing we have to understand when working with Git is the repository, commonly referred to as a repo for short. A repository is the space where all our Git tracking history is stored. We can visualize it as a container that contains all of our change history. This space gets initialized as a folder with the name .git when we run the command git init in our project. Basically, our repo exists in the .git folder. If we delete it, all the change history will be gone. So it makes sense for our first command to be git init, since it initializes a Git repository inside our current directory by creating the .git folder. No Git commands will work inside our project unless Git is initialized first. Our second command is the git status command. We will use this often as it shows us the state of our repository at any time and helps us manage our changes across the Git tracking area. Now that we have learned a few commands, let's go and try them out. So right here, we're in a directory called basic git commands 1, which is basically the name of this lab. Let's see if Git is already working here. If we try the command git status, we will see that it gives us an error saying that this is not a Git repository. What this means is that we have not initialized Git yet inside this directory. To do this, we use the command git init. Now that we've used this command, we'll see that it says we've initialized an empty Git repository in, and that's the directory that the repository is initialized in. So now, if we use the command git status, we will see that it's working. That means that Git is correctly set up inside this directory. Now we know the commands git init and git status. To continue, we need to understand the Git tracking areas. So what are the Git tracking areas? Basically, while working in a Git repository, files can be in 3 areas. The first one is the working directory. This is where you are working on your files locally and can make changes to them. Files in this area are untracked, which means they will not be included in the next commit or save to the repository. Next, we have the staging area. Files in this area are ready to be saved in the repository, or in other words, staged, which means that they will be included in the next commit. Finally, we have the repository. This is where the commit history is stored with all the states of the files at the time of the commit. Let's start by looking at an example. I'm working on a project where I want to categorize the Olympic sports. I have a folder called Olympics. Inside this, I have different files for different sport categories. And I'm using Git as my VCS. While working on this project, I make some changes to the aquatics and martial arts files. I also decide to delete the team games file and add the solo games file. I am now ready to save my changes. Let us see how I can do that. At the moment, my file changes are all in the working directory, and I want them to take the correct steps to be saved. By the way, a common color code for changes is yellow for changes, red for file deletion, and green for file creation. The first thing I have to do is use the git add command. The git add command moves my files from the working directory to the staging area. I can use it by running git add and then the name of the file I want to add. Or I can also add multiple files at once by separating the names with spaces. Finally, I can use a very handy shortcut, which is using git add and then dot. This translates to add all the files with changes to the staging area. Let's try it out. Okay, so first I'm going to try git add aquatic. Because I specified the file name to be aquatics, I can see that only aquatics has moved to the staging area and is now staged. I can add the rest of the files one by one, or I can just use the shorthand git add dot. And now all my changes are staged. Now that I have my files staged, I want to save them to my repository. The term for that is commit. So the command is git commit. When creating a commit, we have to include a commit message. The easiest way to do this is to use the flag -m and then add the commit message between quotation marks. There are other ways to add commit messages involving using text editors and in-terminal editors, which might be confusing and unnecessary. So I recommend using the inline method. A note here, commit messages should give a summary of the changes that happened in the commit, which would allow us to identify specific commits easier and make it easier to go back to them. Now we are ready to save our changes. So we'll run the command git commit with the message updated aquatics and martial arts, replaced theme games with solo games. Commit message phrasing and content can vary between companies and projects. So it's always best to see if the general style of commit messages in any project you work on to stay consistent. Once we run the command, we'll see that our files have moved from the staging area into the repository under the commit we just made. If we open up the commit, we can see all the changes that happened in that commit. The git log command shows us all our commit history on our current branch. We'll get into detail on branches in the next lecture. This is very useful if you want to double check on if our commit has been saved correctly. Also, it helps us see what changes happened in our project and who made these changes and when. This is what a commit looks like in the output of a git log command. First thing, we have the commit hash, which is a number unique to the commit, and it is how Git identifies the commit. So no two commits will have the same hash. Then we have the author username and the author email. Under that, we have the date and time when the commit was committed. And finally, the commit message, which is how, as a reader, you can identify the relevance of a commit. Now that we've understood the Git tracking areas, we are now ready to make our first commit. We will go through the Olympics example that we went through in the slides and see how it translates in a Git repository. So first things first, let's check our Git status. So you can see here that this is not a Git repository. So how do we initialize a Git repository? We just run the command git init. So this folder already has 4 files. So we have aquatics.txt, question.txt, martial arts, and team games. They're all text files. So because we just initialized the repository now, if we run the command git status, Git starts to see these 4 files, and it's wondering what to do with them. At this point, they're untracked. So we said what untracked files are files that will not be included in any commit that we make. So we need to make them tracked. So we need to use the command git add to add them to the staging area. So let's try this by using the command git add dot, and then running git status again, we'll see now that these files are changed. In the status, changes to be committed, which means they're in the staging area now. So what we can do is just add git commit -m to include the message and just say this is our initial commit. And now if you run git status, you'll see that our working tree is clean, which means we have no extra changes. And if we run git log, we will see our commit here, right? So now let's do some changes to our files. We go here. This is my text editor. We have the files open, so we want to do some changes to them. So in aquatics, I want to add another Olympic game, which is water polo. And then I'll add judo to martial arts. I'll leave equestrian games as they are. And I've decided to delete this team games and instead add like a solo games file instead. And we can add golf, for example, to this. So now we've made some changes, right? Let's go back and see what git status thinks of this. So because we've modified aquatics, we've modified martial arts, and we've deleted team games. Okay. So it says here that these changes are not staged for commit. That's expected, right? And we have another new file, which is still unchecked. So how do we stage these changes? We've just done that. We can, for example, add the files one by one. So git add aquatics, for example. And now look at git status again. So you'll see here that aquatics has moved now to changes to be committed, which means it's staged, and the other files are still as they are. We can add them one by one, or we can just use the shorthand git add dot, which will add URL files. Okay, so now what's remaining is for us to actually commit this. So git commit -m, and we can say that we've updated aquatics, and martial arts, and we've replaced team games with solo. This is just the commit message, and then we commit. So to check if our commit has been successful, we could use the command git log. So now we've got two commits. One is the initial commit that we've made, and the other commit that we've done now. So looking at the output of the git log, we can see that the structure of a commit starts with the commit hash, which is the unique identifier for the commit. You'll see here that these two hashes are different, and any commit will, no two commits will basically have the same commit hash, because this is the unique identifier that Git uses to identify each commit. We have the author details, so username and email. We also have the date the commit has been made and the time, and the commit message. So this is our commit message for our second commit, and this is the commit message for our first commit. So there you have it. We've gone through the stages of changing files and adding them to our Git repository. Branches are one of the main features of Git and are essential in Git workflows, especially when working on big projects involving multiple people and parallel development contexts. We will be learning all about branches and how we can efficiently make use of them. Let's first take a look at the linear flow. What we have here is a series of commits where each commit has a collection of information. Firstly, the commit hash, which is a unique identifier for the commit. Each commit has a different hash, and this is how we refer to them if we need to. Secondly, every commit knows what its parent is. As we can see here, each commit stores the hash of the parent commit, except for the first one, since there was nothing before it. Finally, the commit message that we specified when creating this commit, that should give us an idea of what happened in this commit. Moving linearly means that we have to work in one direction, which is not optimal for most workflows, as we usually want to work on multiple things at the same time. This linear flow is all right if we're working alone on a project and the project has a linear plan with no experimentation or any diversions. Since that is almost never the case, we need some way to manage work done in parallel, and that is where branches come in. Let's say we're working on a mobile application. We will have one branch containing the master code, which is the code that we use to release to the App Store or Play Store. Now we want to work on a feature that allows us to receive push notifications on devices. So what we can do here is we can branch off from the latest commit on master and work on that feature. And I can keep adding commits to this branch without affecting the master branch. So let's say while working on this push notifications feature, we get a message from our customer service team reporting an issue that users are having, and fixing this issue is now top priority. We're facing a problem here since our push notifications branch is not ready, so we cannot release it soon. And we need to fix this bug as soon as possible. So what we can do here is we can go back to master and create a bug fix branch from master. Since the changes we made on push notifications are isolated from master branch. After working and making commits to the bug fix branch, we are now ready to release the fix. At this point, we want our changes to be stored on master so we can do the release. We have the ability to combine branches through a process called merge. Merging is a very big topic and we will talk about it in coming videos, but for now, let's just imagine that we've merged the changes on bug fix with master branch. And there we have it. Now we can go back to push notifications and continue working on it. Now I think our feature is ready. So let's do the merging thing again and combine it to master. So now we have all our changes back at master and everything is working correctly. A note on the term master branch, you will hear and read it a lot in your career. This is because this is the default branch name used by Git when you create a repository. Since it's the default branch when creating a repo, it is usually used as the main source of current code. And usually in projects, it contains the code that is released or deployed. However, this is just a common convention, which can differ from project to project. As you can see from this screenshot, when you run the command git init, it tells you that the default name is master, but it also tells you how to change it for all repos going forward, and how to rename the current branch if you want. The most common default branch name after the master is main. It's useful to know, so you know when you're browsing repositories or starting work on projects, you can know what is the default branch. Although it could be anything, but these are just the common ones. Before we get into how to create and manage branches, we need to understand the concept of head. While it might seem daunting, it's in fact a very simple concept. When working with Git, only one branch can be checked out at a time. And this is what's called the head branch. Often, this is also referred to as the active or current branch. Head is basically just a pointer that points to the current commit your repo is on. That commit is usually the latest commit in our current branch. Let's go through our previous example and see where head is pointing at each step. We start at our master branch, so our head is currently on our latest commit on master, which means master is currently our current or head branch. We then want to start on push notifications, so we create a new branch. An important thing to note is that when creating branches, we create them from our current head position. So now that we created the push notification branch and moved head to that branch, we can now start working. As we proceed to work and commit code, the head pointer moves with us to point at the latest commit. At this point, we get the message that there's a bug within the app and we need to fix it. The issue now is push notification work is not finished, so we cannot release it. Here's where we see the advantages of using branches. We can switch back to master, so our head now points at master, and it's our current branch. At this head position, we do not have to worry about unfinished code messing anything up, since it does not yet exist on master. So we can branch off our current head and create a new branch called bug fix. Now our head is at bug fix. We can now fix the bug and commit the code, and our head pointer will move with us. So now that we've fixed the bug, we want to merge the fix into our master branch to create a new release. Now that we have merged the branch, our head is pointing at the latest commit on master, making it again our head branch. Now we are free to go back to working on the notification feature. So we will switch branch again to push notifications, making it our head branch. And after adding another commit and seeing head move with us, we can merge our feature back to master. And now we have head back to master, making it our current branch. A detached head may sound like a serious and dangerous term, but it just means that the head is not pointing at the latest commit in a branch, or also known as the tip of the branch. But instead, is pointing to a specific commit. It is useful to be able to check out a specific commit to see the state of your project at that point in time. You can also make changes from this point and commit. The only catch here is that if you switch back to a regular branch, all the changes will be gone. Unless you create a new branch with these changes, then this branch will have all your changes and head can then point to this branch instead. Now that we have understood the concept of head, as well as the benefits of using branches, let's have a look at how to use branches in Git. The command git branch with a branch name after it creates a branch with that name from the current head location. When choosing a branch name, we want something that's descriptive of the work being carried on. Like in our example, we have a push notifications branch that indicates that we're working on push notifications. Branch naming conventions vary from company to company and project to project. A quick note is that branch names cannot contain spaces. Instead, we separate words using the dash sign. A note on this command is that it creates the branch, however, it does not automatically switch head to that branch, but it stays on the current branch unless we switch. As we now know, branches are created from the current head position. So if I'm currently on master branch and run the command git branch push notifications, a new branch called push notifications will be created, but head will stay on master. If I do not switch to the new branch and decide to create another branch called bug fix, using the command git branch bug fix, a new branch will be created from master as well, since head did not move. So now we have two branches from the same source. If we use the command git branch without specifying a branch name or with the option -- list, we can see a list of branches in our repository. As you can see, the current branch is highlighted in green and is marked by an asterisk. One thing to note is you need to have at least one commit in your repository to be able to use and see branches. This is because head needs to point at something to be able to use branches. Switching between branches means moving head to the tip of the switched branch. To switch between branches, we have two options, either git checkout or git switch. Git switch was added in a relatively recent Git update to have the exclusive functionality of switching branches. While git checkout was the original command, you can use whichever command you prefer. They both behave exactly the same. So let's see what this means. So we have here three branches. To switch between them, we will first use the command git switch push notifications. We will see that head has moved to the push notifications branch. Now let's try git checkout bug fix, and we'll see head moving to bug fix, making it our current branch. Finally, we want to go back to master. We can use git checkout again or git switch, whatever we want, and run git checkout master or git switch master. And there we go. Head is back where we started. There's no order or limit to switching branches. You can switch to any branch you want as many times as you want. So now that we have learned how to create branches and how to switch between those branches, a very common use case is that we want to create a branch and use it immediately. Fortunately, Git conveniently has the ability to do that with just one command. All we have to do is add a flag to the command. The flag depends on what command you are using. For git checkout, we add the flag -b. And for git switch, we add the flag -c. This signals to Git that the branch name you specified is a new branch and you want to create it. Under the hood, all Git does in this case is run the command git branch with a specified branch name and then switching to that branch using git checkout or git switch. So now if you run the command git switch -c push notifications, the new branch is created and we can see that head has moved to that branch. This means that our current branch is now push notifications. And if at this state we run the command git checkout -b bug fix, the new branch bug fix will be created not from master but from push notifications, where our head was. Our last major operator is deletion. The command is git branch -d and then the branch name you want to delete. To delete a branch, you need to switch to any other branch first, as you cannot delete the head branch. Deletion is not very easy to recover from, so Git gives you a warning if you have unmerged changes, and we use the lowercase d flag. If we are sure of deletion, we can use the uppercase d to force delete a branch. If I try to run the command git branch -d master, nothing will happen, as master is currently my head branch, so Git will give me an error and refuse the deletion. Now, if I run the command git branch -d bug fix will be deleted with no issues, since it is merged into master and there are no unmerged changes. If I try git branch -d push notifications, Git will give me an error now saying that there are unmerged changes. That is because the changes on push notifications are not found on any other branch in the repository. So if this branch is deleted, all these changes will be deleted as well. Now let's say I'm certain I don't want these changes and I want to delete the branch anyway. I can run the command git branch -d, but uppercase, and then push notifications. Now the branch is deleted and we only have one branch remaining. We will see the example we talked about in the slides and how it works in a Git repository. So we're standing now inside a folder called branches demo. It's the name of this folder. And we have already initialized Git repo in here. So we can check by running the command git log. You'll see here that we are on master branch and we have one commit, which is the initial commit. You can also see that here in GitKraken, we'll see that we are on master branch and we have the initial commit. Okay. So let's take a look at our application. So we have here one file, very simple app emulation. So in this file, we have the version of the app, and then we have the hidden bug. So it's just a string saying I'm a hidden bug, you can't see me. So this is the bug that will arise at some point and we need to take care of. We don't see it now. And we have our app, just says I'm a mobile app. That's it. Okay. So now we want to start working on the push notifications feature. So we decided to start by branching off into a new branch named push notifications. So how we do this is we type in the command git branch and then push notifications. Okay. So if I now use the command git branch, I will see that I have a new branch push notifications. I will also see that master is still active by the asterisk indicator here. And the fact that it's colored green, that means that it's the active branch. And I can also see this reflection in GitKraken. We'll see that we have master here and the tick mark indicates that it's active. We also have the push notifications branch that we've just created. Okay. To start working on push notifications, we need to first select that branch. So to do so, we will use the command git switch and then push notifications. This now says that we switch to the branch push notifications. We type in git branch, you'll see here that it's now the selected branch. And we also see here in GitKraken with the tick mark. Okay. So now let's start working on the push notifications feature. We'll do that by adding one line saying like push notifications. And also notice here that it's a draft, so it's not ready yet for release. And let's save this work. So we can go back and just commit the changes we've just made. First step, as always, we add the files to staging using the dot prefix as a shortcut to add all changed files. And then we can do git commit -m, and then we can say a message we like started working on push notifications. And now we see that this is committed. We can run the command git log again. And we'll see here that we have the commit started working on push notifications, and we have our initial commit still. If we go to GitKraken, we see here that the branch push notifications has this commit, started working on push notification, as well as the initial commit, because it took that from master, while master is still here on that initial commit. Okay, if we want to double check that, we can switch back to master by using the other switching command, which is git checkout master. And I will see we're switched on branch master, and master is now active with this indication here. And if we run git log, at this point, we will only see the initial commit. That's the only commit here. So that's it for this part. We've seen how working on different branches can have, by working on different branches, we can have different commits on there without affecting each other. So let's continue on our branches demo. Where we stopped last time is when we're on master branch now, and we have our push notifications branch with that initial commit. So now we've got the call that we want to work on the bug fix. So what we can do here is branch off again from master and create the bug fix branch. We learned in our slides that there's a shorthand commit for creating and switching at the same time. So we'll use that. So we'll use git switch, and then we'll add the flag -c, which means create. And the branch name that we want, let's say it's bug fix. So now it's going to say that we've switched to a new branch bug fix. So if we run git branch here, you'll see that we're on bug fix. We still have our other branches. So can have a look at Git Kraken. We'll see that we have bug fix and master on the same commit, and push notification is on its own commit. Okay. Also, yeah, we can notice here that we don't have the push notifications line that we've added, because that's on the push notifications branch. So let's do some changes here. So we found the hidden bug, and we're gonna fix it by just deleting it and then just saving. We can go here and commit the changes we've just made. First, we have to stage the files, and then we commit, let's say, fixed bug. Now, if you run git log, by the way, we can use the flag one line. So git log does not present too much information. We just need to see like the commit messages and find out which commits are here. So we have our initial commit and we have our fixed bug commit. If you go to Git Kraken, you'll see here that master is on initial commit, bug fix is on fixed bug, and push notifications is on started working on push notifications. So each of them is on a different commit. Last thing we want to learn here is how to delete branches, right? So let's try deleting push notifications branch. We know that it has commits that are not on any other branches. This means that it has unmerged changes. So if we run the command git branch and the flag for deletion is -d, and then we write the name push notifications, you see here, because we used a lowercase d, Git is giving us this error that the branch push notifications is not fully merged. And it also gives us the option, if you are sure you want to delete it, to run the command git branch, but with the flag capital D. So let's try that and see what happens. Just quickly take that and then do this. And then it will say like we've deleted branch push notifications. So if we go back to Git Kraken here, we see that we don't have the push notifications branch anymore. If we type in git branch, we see that we're still on bug fix and we don't have the push notifications branch. Now let's, for another example, let's create another branch, git branch, and just name that test branch, for example. We go to git branch here. We see that we have this test branch now. I'm going to clear just to have a clear screen. If we run the command git branch dash small letter d, and then test branch, you'll see here that the branch will be deleted because it does not have any new commits. So when we're trying to delete a branch, always make sure to use the small letter d, like here, just so if there's any mistakes in the branch name, or if you accidentally write in an incorrect branch name, you at least get the warning like this one here, that it's not fully merged, and it gives you the chance to revise this action. And then if you're super sure about it, you can use the capital D flag. Now that we have understood how branches work in Git and their importance in managing work, let's see how we can merge them together. To merge branches, we use the command git merge. The important thing to remember is that when we use this command, we need to be on the branch we want to merge into, also known as the receiving or destination branch. In other words, we merge branches into head. So we need to make sure it's pointing to the required branch when using this command. So the first thing we do when we're preparing for a merge is we switch to the destination branch, and then we run the command git merge with the source branch name. For example, if we want to merge the branch bug fix into master, we run git switch master, and then we run git merge bug fix. There are multiple merge strategies in Git. Merge strategies can be classified into two main categories. The simplest type of merging, which is fast-forward merge, and then we have non-fast-forward merges. Non-fast-forward merges can be one of four subtypes: recursive, hours, octopus, and subtree. These subtypes are not required for regular Git use, so we will be focusing on fast-forward merging and non-fast-forward as a whole. If we do not specify what kind of merge we want, Git will automatically decide on a strategy based on the branches provided. The most commonly used strategies are fast-forward and recursive non-fast-forward merge. Fast-forward branches are very simple. All that happens is that Git moves the branch pointer to catch up with the latest changes. There is one important condition though, is that the branch we want to merge back into has not had any new commits since we branched off. Let's visualize this. We have here the master branch, and it currently has 2 commits. we can see that the master branch pointer is pointing to the second commit, and the head pointer is pointing to that branch pointer, which means that master is currently our head branch. So now we want to work on a new feature. So we'll make a new branch for it and call it feature. And then we switch to that branch. After we do some work here, we make a commit. And then finalize the work and make a new commit. Now we are done with the feature. Now our branch is ready to be merged back into master. So we will follow the steps we just learned. Firstly, we will run the command git switch master to switch back into master. Now let's run the command git merge and see what happens. As we just saw, what happened is that master branch pointer moved to point to the commit F2, which is the latest commit in the feature branch. So now both master and feature branches are pointing to the same commit, and we can continue working from master from there. In summary, the branch pointer was fast forwarded to the latest changes. So now let's take a look at our first type of merges, the fast forward merge in a Git repo. Here we have a repository named pets. Currently, we only have master as a branch. So let's take a look at what's inside this. This is our repository in the text editor. I'm using VS Code, by the way. So we only have a file called dogs.txt, and it has 4 breeds of dogs. And if you go here to GitKraken, we can see that we only have one commit, which is the initial commit, and it's on master. Okay. So now we want to add cat breeds. So let's create a new branch. We're going to use git switch -c and call this branch cats. So now we run the command git branch. We know that we're on cats. And we can see that here. And here we're just going to create another cats.txt file. And I already have some cat breeds here. And I'm going to save this. Okay. So now we've added our cats. Let's commit this. We can do commit from various places. We can do it from the editor. We can do it from here, by the way. That's just another way to commit. You can use the GUI you're using. So I'm going to just stage the file. This is equivalent of using git add. And then here we can write the commit message, added cat breeds, and then we can just commit. So now we see that our master branch is still on initial commit, and cats is on the added cat breeds commits, right? If you go back to the terminal and run git log here, we can see that we have the 2 commits here on this branch. And now it's time for us to actually try merging. So we agreed the first step is we switch to the branch we want to merge into. So let's switch to master. And just to check git log, see it only has 1 commit. So now we're ready. The command we're going to use is git merge and then just cats. You see here, it says fast forward and 1 file changed, 5 insertions. This is just the specification of what was changed. And if we run git log here, we'll see that now we have the 2 commits as expected. If we go to GitKraken, we'll see that master is now on the added cat breeds as well. So all that happened is master moved from here to here. So it was just fast forwarded. Non-fast forward merges are required when we have made more work on the destination branch after branching off from it, which means that we cannot just simply move the branch pointer instead. Git creates a commit on the destination branch that combines the changes that happened on both branches. Let's go through the previous example again and see what would be different. We'll first branch off a master, and then move head to feature. We'll make our first feature commit. Now we make our last feature commit. We are now ready to merge, but we notice something. That master has another commit that we don't know about. So we can't just fast forward the master pointer since we'll lose our M3 commit. The process is still the same. So let's go through it and see what Git does. First, we run git switch master to go to the master branch. And then we run git merge feature. As we can see here, we now have a commit that has 2 parents, one from master and one from feature. The purpose of this commit is to combine the changes that have happened on both branches and merge them together. Let's take a look at our second type of merges, the non-fast forward merge in a Git repository. We are going to use the same repository we just used. So we're in pets. Let's check what branch we're on. We are on the cats branch, and now we can start making some changes. So we're still on the cats branch, so let's add another type of cat, long hair cat, for example, and save that. And we're going to commit the change we just made. Added long hair cat. Okay. So now that we've got this commit, let's switch to master. And on here, let's make a change to the docs file. For example, let's remove this last breed and save. And now let's commit this again. Removed a breed. Okay. So let's check out what our branches look like on GitKraken. We have here cats on added long hair cat, and we have master on remove the breed. So as you can see, we can't make a fast forward merge here because we have different commits. So let's try the same merge command as we are now on master. Let's check that branch or on master. That's correct. And now let's git merge cats. So you see here that it asks me for a merge message. That doesn't happen in fast forward merges because we're creating a new commit and it needs a merge message. So let's leave it as is, merge branch cats. And if we close this, the merge should happen. And we can see here that merge was made by the ORT strategy. That's one of the subtypes of non-fast forward merges. And we have all the changes that we need. If we run git log, let's see here that beyond the extra commits that we have on the branches, so added long hair cat and remove the breed, we have also the merge commit, which is merge brand cats, and we can see that in GitKraken as well. So now you see here, this is the merge commit. Merge conflicts happen when we make changes to the same area on both the source and destination branch. So when we ask Git to merge these branches, it doesn't know which changes to keep. In this case, we have to resolve it manually. Git helps us to resolve these conflicts by adding something called conflict markers to the conflicted areas, and then asking us to decide which changes to keep. Let's see how this looks like. Here we have a file docs.txt with a list of dog breeds. We are trying here to merge the branch demo into master, which is our head branch. In this case, we have made a change to the shepherd breed in both demo and master. The lines between the less than signs, followed by head, and the equal signs are the changes from the head branch. The lines on the other side, between the equal signs and the greater than signs, followed by the incoming branch name, in this case demo, are the changes from that branch. To fix this conflict, we can accept either changes, meaning we can keep one and delete the other, or we can choose to keep both lines. It all depends on the situation. The most important thing is that we remove these markers before committing the conflict resolution. Let's now see how merge conflicts can happen and how we can resolve them in practice. So we're still on our same repository or on pets. And in this case, we're now on master branch and we're going to make some changes to the cats file. So I'm going to change the Scottish fold cat to the English fold. So what I'm going to do here is I'm going to go back and commit this. Change to English. Okay. So now we've got this commit. We're going to switch to cats and go back. We'll see it's still Scottish here because the change was not on cats. And instead of English, we're going to name it Irish. And we're going to commit this. change to. Okay, so now if we check the commit history, we'll see here that we have change to English on master and change to Irish on cats. So we have two different commits. Let's now try merging this. So I'm going to switch back into master. And I'm going to try git merge cats. So we'll see here auto merging cats conflict. So it says here that there's a conflict and the merge failed. We need to fix the conflict and then commit the result. So what happens here is in the editor, we'll start to see here the conflict and how to resolve it. We see here the conflict markers, the less than signs, head. These are the changes in the master branch. So the current changes, because we are currently on master branch. And these are the changes coming from the cats branch. So the incoming changes. On VS Code, the editor I'm using, I can just click any button of these and it will resolve the changes. So I can either accept the current change and keep English, or accept incoming change and keep Irish, or accept both changes, which will result into us having both types of cats. So in this case, let's just try accepting both. So all that happened here is just they removed the conflict markers, and now we can just save this and commit it. So we need to commit the resolution, resolve conflicts. And now let's take a look at GitKraken here. I'll see here that we are now merged back. The commit message I wrote, resolved conflict, is the merge commit message. Obviously, you try to make it more descriptive, but for just this case, it's fine. We all make mistakes. That applies to Git too. Sometimes we can commit stuff that we don't mean, or in the wrong branch, for example. Git provides us with some solutions to that. So let's explore them. Let's start with the first option, the Git reset. Git reset allows us to reset our branch to a specific commit. This deletes any commits that happened after our reset commit. Git reset changes the Git history by deleting commits, so we should only use it if we have not shared the commits with anyone else, as this will mean that we have different Git histories, and that is hard to fix. We use git reset by running the command git reset followed by the commit ID that we want to reset to. By default, git reset will delete the commits, but we'll keep the changes in the working directory in case we want to use them. If we want to delete the changes from the working directory as well, we can use the --hard flag. Let's take a look at this example. Here we have 4 commits. We want to reset our branch to commit number 2. So we run the command git reset followed by the commit ID of commit 2. As you can see here, the commits 3 and 4 have been deleted and master is now pointing to commit 2. Git revert is another way to undo changes. However, the difference is that git revert creates a new commit that contains the inverse of the changes of the commit we want to revert. So, for example, if we added a line in the original commit, that line will be removed in the revert commit, and so on. Because git revert adds a new commit, it does not affect the git history. So it is a safe operation even if we have shared the commits. We will be prompted for a commit message when using git revert. There might also be conflict when reverting older commits if the changes have been modified further. So we will need to resolve these conflicts in order to proceed. The usage is very simple. It is just git revert followed by the commit ID that we want to revert. In this example, we have 4 commits. We realize that we want to revert commit number 4. So we run the command git revert followed by the commit ID of commit 4. What happens here is that Git creates a new commit, which cancels out the changes in commit 4, and now master is pointing to that commit. We will take a look at how to undo changes in Git. We will look at git reset and git revert commands and see what's the difference between them. So here we have a repository called undoing commits. In this repository, we have 4 commits in addition to the initial commits. Each commit corresponds to a line in this file. We have here commit 1, commit 2, commit 3, commit 4. Each line was added in a different commit, And you can see this history here in GitKraken as well. Okay, so now let's see how we could go about resetting to commit number 2. We can go back to the terminal here. We'll see that we have a commit ID for commit number 2. It's this commit ID. So let's copy that. And we just use the command git reset and then copy this ID. Now, if I run the command git log, one line, we will see that commits 3 and 4 were deleted. They are no longer in our history. If we go back to GitKraken, we'll also see this as well. So the weird thing here is that we still have the content from the commits 3 and 4. We still have commit 3 and commit 4 here. Let's try committing them again. I'll call this commit 3 and just commit that. Now, if I run git log again, I'll see that I have commit 3, right? So previously, we've seen the changes commit 3 and 4, even though we resetted our git history to commit 2. That's because we ran the command git reset normally, without the flag hard. So if we try to run it again, using the flag -- hard, let's see what happens here. If you go to our code, we'll see that the lines in commit 3 and commit 4 were deleted. That's exactly what the flag does here. It's just, it resets the git history to commit number 2, and it removes all the changes from the working directory as well. And that's it for git resets. Okay, now I've reset the repository to the exact state we started in. So if we go here to git log again, I'll see that we'll have the 4 commits in addition to the initial commit here. And we'll see that here we have all the changes that we've made, right? So now let's try using git revert instead. Let's say we want to revert the changes we've done in commit number 4. So basically we want to remove this line. All we have to do is get the commit number 4 ID, copy that, and then run the command git revert, and then paste this ID. It will prompt us to enter a commit message. The default is just revert followed by the commit message of the commit that we just reverted. So I'm just gonna use that revert and close this window. Now, if we go back here, and let me just clear so we can see better. If you go back here and run the command git log, we'll see that we have a new commit that says revert commit 4. And if you go to the file, we'll see that commit number 4, that line no longer exists. Let's go to GitKraken here and see what exactly happened in this commit. We can go here and we see that we changed demo.txt by just removing that line here. Usually, there are some files and folders in our projects that we never want to track. To prevent Git from accidentally tracking them, we use .gitignore. .gitignore is a file that's created at the root directory of the repository, and it allows us to specify the files and folders for Git to ignore, hence the name. So what kind of files we want to exclude? First thing, we've got secrets, credentials, API keys, or basically any confidential info that can be considered sensitive information, and we might not want to have them in our repository, especially in the case of public repositories that we don't control access to. Log files. These are created as an output to our project and are not necessarily useful to track. Dependencies or packages. These are external packages that we use in our project, and they can be generated by local commands, so it makes no sense to include them, especially if there are a lot of packages and it will make our repository heavier. Operating system files. These files are irrelevant to our project but are created by the OS for its own use. This is an example gitignore file. As you can see, it includes a few entries. First thing to note is that anything after the hash icon is grayed out. That means that it's a comment and we can write anything we want in the comments and it won't affect the file's functionality. Our first entry here is API_keys.txt. This is an example of sensitive information that we want to ignore. This entry is written as the exact file name, so this is indicated to Git to ignore this file only. Next, we have an example of ignoring dependencies in the form of node modules. We can see here that it's followed by a slash, This indicates that this is a directory and instructs Git to ignore the whole directory and anything in it. Then we have the OS files. A very common entry you will see in a lot of gitignore files is ds_store, as it is generated by macOS in a lot of directories and it has no value. Finally, we have *.log. The star or asterisk here means to ignore any files with the extension .log. This is just a small example of a gitignore file. You can find a lot of gitignore templates online, tailored to the specific type of products you are working on. Let's take a look at the gitignore file in action. Here we've got a gitignore repository, and this is what it looks like. We have the gitignore file, the ignored.txt document, the normal.txt document, and we have an ignored directory. So if we go into the gitignore file, we will see here that we have specified that ignored.txt to be ignored and ignored directory to be ignored. Let's see what happens if I do some changes in a normal file. So this is a normal file, and this is a change. And now that's saved. If we go here and run git status, you'll see here that we say, it says here, modified normal.txt, which is the expected behavior, right? If I do the same in the ignored file, we'll see that here, say this is a change, and save that. What I expect here if I run git status is to see that this file was modified as well. But because this file is specified in the gitignore to be ignored, Git does not track it. It doesn't tell us that this file is modified. So we can go ahead and commit this if we do git add dot, which adds all our changes to staging, and then git commit -m modification, for example. This is now committed. And the ignored.txt file is still ignored. We can also see if inside this ignored directory, I created another file. Let's say this is another ignored file.txt, and save that. If I run git status, you'll see there's nothing that Git picks up because this file was created inside this ignored directory. If I create a normal file somewhere else, just like here, another normal file.txt, you'll see here if I run git status that we have this untracked file. So this is basically what git ignore does. The git config command and how to use it to change some of the Git properties. Here we have a repository called git config, and this repository has one commit. Let's see what this looks like. So we run our git log command. We see here that we have this commit m1, and the author details are displayed here as afifi1, and the email is afifi.git@gmail.com. These are the default values. Now, if we want to change them, we use the git config command. Now we can specify the scope, whether we want to change these values only for this repository, or if we want them to be the default for any repository going on. If we want to change them for only this repository, the scope is --loc. This is also the default scope for Git. So if we don't write this, it will automatically apply locally. So let's try. We'll try to change the user.name property locally. So we'll not write any scope and just change this. So changing the username to Ahmed Afifi. This is local. And then we could try changing the email, but this time we'll make it global. So user.email is the property, and we'll change it to ahmed.afifi@gmail.com. Okay, so now let's try making another commit. For this, I will add a file using the command touch. Touch just creates a new file in the directory we're in. So we just touched new file.txt and we'll add this and then commit. We'll put the message added new file. And now we have our commit. Let's run git log. We'll see here that these values have changed. So it used to be Afifi1, now it's Ahmed Afifi, and then the email has also changed from afifi.git to ahmed.afifi@gmail.com. So now that this is done here in our repository, let's see if the scope we specified here has made any difference. So I'm going to create another repository using the command mkdir, which is make directory, and we'll name this git config2, for example. I'm going to cd to git config2, and first thing we do when we're creating a Git repository is we run git init. And because this was already existing, I see the issue here. I cd'd inside our git config repository, not the git config2. Oops, looks like I've cd'd into the wrong directory. So I'm just going to change that. cd git config2 this time. And then we git init. And this creates our Git repository here. Now, let's try to create our first commit. So let's create a new file. And let's add it. And then commit. Let's say this is our initial commit, for example. We run git log now. You'll see here that our email is retained from the change we made because we've made it global. So we have a new email, but the username has stayed to Afifi1, which was the default name before we changed it in our repository. So that's basically it. If you want to change anything to be the default going on, we use the global flag. If we don't, and we just want to use it in this specific repository, we just leave it blank.
All right, so now that you know a great deal about what Git is, let's start with GitHub, which is what you will use on a day-to-day basis in your IT career or even in your non-IT career in your company or with your team and so on. Back to Ahmed, let's hit that.
What we have learned so far about Git was all local to our machines, and we did everything locally, and we did not need to collaborate or share that with anyone else. GitHub is a web hosting service for Git repositories, which means that the repositories we were working on locally can be uploaded to GitHub and can be accessed remotely. This opens the door to collaboration, where multiple people can access the same repository from anywhere in the world. In addition, GitHub provides a lot of features that help with managing projects, like access control and issue tracking, for example. In summary, this is what our repository looks like on our computer. Then GitHub allows us to push that repository to the cloud, which then allows us to pull the repository on other devices, as well as keeping all the changes in sync. We can only clone repositories without an account, but if we want to create our own repositories or upload any changes we make, we need to create an account. Luckily, the process is very simple and, more importantly, free. To create an account, it's very simple. Just go to github.com. You'll face this landing page. They change the landing page as often, but you can just use the sign up button and it will get you here to the sign up page. All we need to do is enter our email. Okay. So I'm going to use this email and then you have to create a password. And then you choose your username. Username is what will appear next to any contribution you make. If you create a repository, if you commit or create a message or anything, that's what will appear. So choose your username wisely. So I'm going to choose AFEF4 as my username. And then we have here the option to basically like subscribe for like announcements and updates and stuff. And I need to do a verification. And that's it. You'll get a code sent to the email. I have it open up here. Obviously, the codes change per user and they expire once used. So you can just copy. You can create like finish up this survey, but it's not really necessary. You can just skip it. And now we're getting sent into the world of GitHub. So this is what our dashboard looks like. Obviously, we don't have any repositories. We have nothing. We just created our account. So let's go ahead and see what our profile looks like. So this is currently our profile. We have here our overview, repositories tab, projects, packages, stars, etc. A lot of things, a lot of features in GitHub that we can cover later on. So obviously we don't have any repositories. This graph shows your interactions with GitHub. This is today. We just created GitHub, so this is the only time we've had any interaction. And yeah, some timeline of our activities. Now let's jump into repository and see what it looks like. So I'm going to go to the Facebook-React repository. And this is what the repository looks like on GitHub. We have here our code. This is the branch selector. We have here, we know that we have 85 branches, 141 tags. We can switch between the branches if we want to. So just switching between the branches, and the information here switches with it. Let's go back to the main branch. This is the latest commit on that branch, happened 5 days ago. We have here 15,461 commits, so that's a pretty big repository. We can look into the files here if we want to. Just open any file and see its contents. So this is how we navigate the repo on GitHub. Below the code, we have the README file formatted like this, so you have an idea what is the repository you're on. So here React is a JavaScript library for building user interfaces. That's basically what this repository is. We can also access profiles on GitHub and see what they've done. So let's take this guy, for example. Yeah, he has done the latest commit on this repo. So let's search for his username. And filter by users. And we'll see here his profile. Now, because this is an active profile, you can see the history and the interactions. So this is what his interactions look like on this day. For example, he had 5 contributions. On this day, he had 11. So it's more, what's it called, more opaque. The more you have contributions on a specific date. And this is like the timeline. Obviously, these are all public repositories. So they're available for anyone. If he's been working on private repositories, we wouldn't be able to see them as they would be private. Yeah, we can see a list of repositories he has, projects, packages, etc., depending on what he's actively contributing on. And that's, I guess, a brief overview of what GitHub looks like. Now that we've created an account, we need to add an SSH key to authenticate our local device to interact with our GitHub account. Using the SSH protocol, we can connect and authenticate to remote services and servers. With SSH keys, you can connect to GitHub without supplying your username and personal access token at each visit. When we set up SSH, we generate a key pair. One is the public key, and the other is the private key. The public key is shared with GitHub, and the private key stays secret on the device. The SSH protocol checks that the keys are compatible to authenticate the device. We'll see how to use SSH keys to authenticate GitHub. All we need to do to create new SSH keys and add them to GitHub is follow the documentation on the GitHub website. So this documentation explains how we can implement SSH authentication. First thing we have to do is to create the keys, and that's what we're going to do here. On the top of the page, we can choose what platform we're running on, if we're running on Mac, Windows, or Linux, and that changes the steps and the codes, the commands that we're going to use. So I'm currently running on Mac, so that's what I'm going to be using. First thing we have to do is creating the key. All we need to do is open terminal and paste this command while changing the name here to our, changing the email here to our GitHub email. So let's do that. And now we're generating the key pair. I will leave the ID name as it is. And now we can enter our password, confirm the password, and that's it. Now we have generated our SSH key. So after generating the key, we need to add it to our SSH agent. To do so, we just use this command. And we have the confirmation here that our identity is added. Now all that's left to do is to authenticate this with GitHub. So we can follow the GitHub guide again. And you'll see here that first thing we have to do is copy the contents of our key. So let's do that. Now this is copied to our clipboard. And we can go to our GitHub account and follow the steps mentioned here. So we open our settings page and then we add our SSH key. So let's do that. Settings. Now on the left here, we'll see SSH and GPG keys. And now we can add a new SSH key. We can name it whatever we want. So in this case, I'll name it my MacBook key. And paste the contents. That's it. Now we can see that we have our SSH key in GitHub. When we have a repository stored in the cloud, or in other words, not local, it's called a remote repository. A remote repository is referenced by its URL. Every remote repository has its own unique URL. On GitHub, this looks something like this. github.com/the author account name, in this case, it's Facebook, and then followed by another slash and the repository name. In this case, it's React. For our local repo to know which remote repository to point to, we need some way of identifying it. We use the command git remote to add the URL of a remote repository. Every remote we add consists of a name and URL. The URL points to the online repository in this case. To add a remote, we use the command git remote add, then the name of the remote. The name could be anything that we specify. Usually it's origin, followed by the URL of our remote repository. For example, here we will add the remote with the name origin and make it point to an online Git repo with this URL. A note on the name origin that it's the default remote name, and you can set it to anything you want, but origin is the standard. Here's a visual example of what happens with the git remote command. We have a remote repository on GitHub, and we are working on a local repository that we want to connect to this remote repo. To do so, we use the command git remote add. Then we name the remote origin and add in the repo URL. This creates a communication layer between our local repository and the remote one. See how to create and link a GitHub repo using Git Remotes. So first things first, we have our repository here on our device. It's called remote demo. First thing we do is we initialize this repo with git init. Then let's just create a file using touch and call this file demo.txt. And as usual, we'll git add and then git commit -m initial commit. Now, if we do git log here, we'll have this commit where we just added this demo file. Okay, so that's the status of our local repository. Let's see how we create a repository on GitHub and how we can link both. So here's our GitHub page. We just have to do here, click on the new repository button, and now call this repository a name. We'll go with remote demo. Then here we can add a description. We can choose the access level, so it can be public, where anyone on the internet can see this repository. And it can be private, where you choose who can see and commit to this repository. So we don't need it to be private for now. So we'll just create a public repository and click create. Now we've got a repository. We can take this URL. That's our repository URL. You'll see here it's github.com followed by a slash and then the username and then the name of the repository. So now that we've got this, it's time to link up this repository with the one we just created. So how do we do that? We do it using Git Remotes. We use the command Git Remote and then add. We have to name this remote something. So we'll use the default, which is origin. And then we paste in that URL that we just got. And now our repositories are linked. However, we cannot see a reflection of that here since our code is still local. The way we can fix that is we can use the command git push. We'll cover git push later in the videos, but we can just use it now to demonstrate how our repositories are linked. So we're going to try git push, but because this is the first time we use the git push command on this repository and we haven't linked that branch yet, we need to use the option set upstream and then name of the remote, origin, and the branch we want to connect to. So this is what our command looks like. And now we have successfully pushed our changes. And you see here that this branch is linked to master on origin. So origin-master is this branch here. If we refresh, we will find that we have our demo.txt. So now that we've done this, we can just use git push much simpler. Let's try creating a new file, touch demo2.txt, and then we'll add this and commit it. Commit to, for example. Now we've got a new commit. To just push it to our remote repository, all we need to do is just write git push, since it's already configured from before. Now that's done, can refresh here, you'll see both our files. Another option that we have that connects remote repositories with local ones is cloning. Cloning is basically making a copy of the online repository to our device. Cloning also downloads the full Git history along with the files so we can navigate the repo and branches locally. We can clone any public repository without any restrictions or permissions. Cloning automatically adds a remote to the cloned repository. So how do we clone? The command is very simple. It's just git clone followed by the repo URL. For example, if we want to clone the React repository, React is a very popular web development framework by Facebook. We will run the git clone command followed by the URL pointing to the repo. Let's look at this example. I am now on my laptop and don't currently have a repository. I take a look at GitHub and find a repository that I think is interesting and want to work on. I need to download it to my laptop. So I run the command git clone with the repo URL, and now the repository is on my device and I am ready to work on it. We'll see how to clone a repository from GitHub. So first thing we've got to do is create this repository. So we're going to create a repository from here. Going to name it cloning demo. And we're going to add a README file. And now we'll click create repository. Now we've got this repository with the README file and only has the title cloning them. So now we want to get this repo on our device. So what we're going to do here is copy the URL and go into our folder. This is just a regular folder, does not have Git initiated. And we're going to run the command git clone followed by the URL that we've got. And now we have this repository now locally. So we can go into the directory and we can open it in our editor. As you see here, we'll have this README file. We can edit it here. Add, for example, so instead of cloning demo, it's cloning demo 1 and save. And let's commit this. Let's say edit README and commit. And since we've cloned this from GitHub, so the remotes have already been set up, you can just run the command git push. And basically, you'll see our changes here if we refresh. And that's it. Now we've linked our remote repository with our local repository. In this video, we will talk about the git push command. So now that we have our remote, it's time for us to push. Pushing is basically uploading the git changes we make locally to our remote repo. To push a branch, we use the command git push, then the remote name, followed by the branch name. In this example, we use the command git push origin master. The keyword origin in this command is just an alias to the URL of the remote repository. Let's see what pushing is like in an example. So here we have our local and remote repositories. On the local repo, we have our master branch, which has a few commits, and we currently have only the initial commit in our remote repository. So let's start by running git push origin master. Now, our remote repo has the latest master branch. We continue working locally and add a commit to master. But our remote repo does not know about that yet. So we need to run the command git push origin master again for it to catch up. So now we have our repo sync. If you have another branch locally, like so, we will have to push it as well. And in this case, we will run the command git push origin feature. So now our repos are in sync again. We will see how we can use git push to update our GitHub repositories with the latest changes. First thing we've got is our local repository called GitHub demo. First thing we do with any repository is just initialize it. So GitHub init. And then we will create a file for demo.txt and commit that file. So first we do git add and then git commit -m initial commit. Now we've got our commit. So let's link this up with our remote repository. Here we've got our remote repository. To link it, we'll use the git remote command, and we need to copy this URL. So we'll use the command git remote add, and then the name we want for our remote origin, and then paste in that URL. So now our repository is linked to the GitHub repository. So let's try pushing our changes. We use the command git push. This is what will show up. So it says the current branch master has no upstream branch. That means that it does not know where to push the stuff. It is linked to the remote repository, but it does not know exactly what branch to push to. So Git provides us with this option. We can use this command, git push -- set upstream origin master. That means that whenever I tell Git to push, it knows that it will automatically go to origin master. So if I do this, we will see that our changes have been pushed and branch master is now set up to track origin master. So our branch here, we do git branch, we'll see that it's master and it's set up to track, let's refresh this for a sec. It's set up to track this master branch, which is the branch master on the remote origin, which we just added. Okay, so now if we want to push again, you can simply just use git push. So let's just make a new file. And then add it. Okay, so now we've got our second commit. Instead of you having to specify that we want to push to origin master, it's automatically set up. So we can just use git push, press enter. And now you'll see that we've got both of them here and everything is linked up. We'll talk about the git pull and git fetch commands. Pulling is the opposite of pushing, as in we get the latest changes on the current branch from the remote repository and merge them directly with the current working directory. This is especially useful if work is being done by multiple people on multiple devices. The command for that is very simple, just git pull. Let's take a look at this pulling example. Here we have the master branch with multiple commits on the remote, and we want to update it locally. So we use the command git pull. Now we have the latest changes on local. While we were working, someone pushed a new commit to master. To get this change, we run the command git pull again. And now we're all in sync. Git pull is made up of two separate commands, git fetch and git merge. Git fetch gets the latest changes from the remote repo, but does not merge them into the working directory. Instead, the changes will be in the remote tracking branch, which is an exact copy of the remote branch, but is stored in the local repo. We use git fetch if we're not ready to merge the remote changes now, but still want to keep our local repo updated. The command for it is just git fetch. We covered the Git tracking areas before. Now we have one more area, which is the remote repo. Let's go through the flow with this new addition. To get from the working directory to the staging area, we use the command git add. Then we can use the command git commit to commit the changes to our local repo. Now we can use the command git push to push to the remote repository. We can also go the other way around by using the command git pull. We can get the changes from the remote repo and apply it directly to the working directory. Or we can split it into two commands. We can use git fetch to get the changes from the remote repo and keep them in the local repo, and then git merge to merge these changes into our working directory. We'll see how to use the git pull and git fetch commands. First, we've got this GitHub demo repository that we've created, and we can open it in the editor to check what it looks like. We'll see here that we have this demo.txt file and demo2.tx. These are just two separate files that are empty. Now we can go to our GitHub repo. This is the same repository, GitHub demo. And we can go to this demo.txt file. You can click on this pencil icon, which means edit. And we can add a line here. Say like, this is a git pull test, for example. And now we can commit directly from GitHub. And we've got this change. So now, if we go back to our repository, we'll still see that we don't have the change as we have not yet pulled. So what we can do here is just run the command git pull. And now if we open the editor again, we will see that the line automatically shows up. So this was the git pull command. If we want to split the command into two, we've got git fetch and git merge. So let's see how that looks like. First, we'll do another change to this file. Let's just change this to this is a git fetch test this time, and commit that again. So now, if we use the command git fetch, we will have the information here. So it's already fetched from the remote repository, but it does not reflect in our code. So if we look at this here, we still have only this line. We don't have the second line yet. The second step, if you want to complete a git pull flow using git fetch, we have to use the command git merge, which basically merges the remote tracking branch into our current branch. And we can take a look here. And we'll see that we've got this fetch test automatically applied into our working directory. We'll talk about pull requests and their importance in a collaborative environment. Pull requests, or PRs for short, are a core feature of GitHub that allows us to review changes. PRs let us tell others about the changes that we've made, and they are essential in maintaining the quality and relevance of code in projects. By reviewing changes before merging them, we can make sure that bad code does not get into our project. PRs are opened once changes are ready to be merged. They are then reviewed by relevant team members, and you can discuss the changes together and incorporate any feedback that before merge. PRs can be accepted or rejected. Reviewers can add any comments and feedback, and the PR creator can respond and fix any issues. Once accepted, the changes can then be merged. Let's look at this example. We have our master branch, and we want to implement a new feature. So we create a new branch feature. We do some work on this branch, and we are ready to merge it back into master. Now, because we are collaborating with people on this repository, instead of merging directly, we open a pull request. Our team can then review the changes and suggest any improvements. For example, or if everything looks good, they can approve the PR and we can merge. We'll take a look at pull requests on GitHub. So here we have a repository called PR demo. In this repository, I've got a README file, and it's created using this user, AFifi3. And we've also added a collaborator on this, which is my other account, AFifi2, which you can access from here. So we have two separate people working, or two separate accounts working on the same repository. Let's see how the flow of changes can go. So here we have the main branch, and we want to add a new feature. So first thing we're going to do is create a new branch called feature. We can do this from here. And now we've got this new branch. You can then edit this README and add a line saying this is a feature and commit these changes. Now we've added our feature. We want to open a pull request. You can go to pull requests and create a new pull request. The base branch, you have to choose which branches you want to pull from and pull into. So the base branch is the one we want to pull into, which is main, and we want to pull from feature, so we can have our new change. And here we have a summary of changes. We can create this pull request. This is the pull request title, and we can add some information here. And create this pull request. If I want someone to review this pull request, we can add the reviewer here. So we're going to do this for a second account. Now, if we go here, you can see, if we go to our notifications, that there is a PR open and requires a review. Says that this account has requested a review on this pull request. And we can start adding a review. Now we see this feature. Maybe I want to add a comment here. Update to new feature, maybe. And we can start a review. Then, when we are done reviewing the changes, we can finish our review and choose one of these three options. You can either comment, so this is just general feedback. It does not need approval. And we can also approve the pull request, and we can request changes. So requesting changes tells the other person that something needs to be addressed before merging. Approving means that we're ready to merge, so there's no problem. So let's do request changes. And now we can see here on this window, it says that changes are requested. And it says who requested these changes. If you go back to our original account, we can see the same thing. So we have an option here to actually address the comment and maybe change our code. Normally, this would happen locally on our device or on GitHub. Does not really matter in this case. So it says update to a new feature. So instead, we're going to be saying this is a new feature and commit those changes. Now we can go to the pull request. You'll see that the pull request will be updated now. It says this comment was on an outdated file. So our changes have been updated. We can then ask for a review and go to our second account. And we see here that there are new changes. So we can view these changes. And then we can review and approve. If we submit this review, everything will turn green here. It says that the changes are approved, and we've got approval on this pull request. So we're ready to merge. So we can go back to our original account and merge this pull request, confirm this merge. And now, if we go to our code, you'll see that the main branch, has this new feature. And that's it.
All right, hopefully the course was a beneficial one. And as I stated earlier, this is very important skill even for the writers, for the auditors, for the proofreaders, because any time you would like to use the computers and you are going to edit some files and you would like to have different versions of these files and you can rewind or move forward between versions, then Git and GitHub is going to be a key skill that you need in order to save yourself a lot of hassle of saving 200 copies with different names of your file on your computer. And if you delete one by mistake, that's it. You can't recover it again. All right, so if you have not subscribed, please subscribe to the channel and activate the notification so you will get all the updates about our videos, and also support us with a like and share the channel so we have more people and we can benefit the masses. This course is part of what we call the self-study multi-cloud and DevOps program. So it prepares you for multi-cloud certified professional and also for DevOps. And if you scroll down, you'll find that there is the foundational information, and we have Linux Mastery, we have AWS Cloud Practitioner, and then we have the Git and GitHub course. So if you would like to get the full version, be our guest. You can get that yourself, and it is about 3 hours of video content. So there is a lot more advanced stuff that you can benefit from. And if you would like to know exactly what is the curriculum, then you can find it here. And if you would like to enroll in the program as a whole, then this will be the page, and these are the steps, the different steps that you can get to. Where did we get to that? Once again, it was from the home page, and then we scrolled down, and this is the first link for the self-study program that you have had. Okay, you get to access for 2 years and all of these courses: mastering the basics, Linux mastery, cloud practitioner, AWS certified, Git and GitHub, Python scripting and automation, YAML, Docker and Kubernetes, infrastructure as code, Terraform, CI/CD using Jenkins and GitHub Actions, and also the Ansible, RHCE, Red Hat Certified Engineer, AWS Cloud Solutions Architect, and the Azure Fundamentals. So you get 5 certificates in the bundle, and you get access for 2 years, which can help you completely reinvent your career. All right, one last time, subscribe, activate the notifications, and I'll see you in the next video. Hopefully this was a beneficial video and it was a good investment of your time. Ciao.